Hi students. In this lecture, I am going to discuss electric potential due to dipole. So in the last class, we have discussed calculation of electric field due to dipole, right? So this is now about electric potential due to dipole. So first we discuss on axial line, then on perpendicular bisector, and third one at a general point. Okay, let us see now. Right, let us consider a dipole. Take first charge minus q, other one is a plus q. Let us take separation between these two, that is 12. We want to calculate potential at a point on the axial line. Axial line means it is a line joining both the charges. Let us take now distances r from center of dipole up to that point P. Okay, then see what we get here. Because of positive charge potential, it is a kq into 1 by distance from positive charge, that is r minus L, right? See carefully, from midpoint of dipole up to P r. So from Q to P, it is r minus L, right? Next, because of negative charge, potential is negative. So I'm taking negative minus kq by r plus L, right? Then see what we get. So first one because of positive charge, second one due to negative charge. Since charge negative, potential is negative. So here I have taken negative side, okay? Right, remaining is R plus L, this is R minus L. It becomes 2L, right? It is KQ into 2L. Now this becomes R square minus L square. R square minus L square. That is equal to, in the place of Q into 2L, that is taken as dipole moment. Remaining is Kp, and we are knowing that separation between the two charges is very small. That means when L is very small compared to R, this can be taken as approximately, right? Approximately Kp by R square. That is the potential on axial line. Okay. Right. Now let us focus on bisecting line. See that carefully. That is minus q less q. Now we are taking just one line which is passing through midpoint. That is what we call perpendicular bisector. Okay. And if you observe carefully, any point on this line will be at the same distance from both the charges. I am repeating, if you consider any point on the bisecting line, its distance is same from minus q and plus q, right? When distance is the same, because of negative charge, potential negative, Because of positive charge, potential positive, and sum of those two will be zero. Means at any point on the perpendicular bisector will be potentially zero. Or same thing, we can extend that if you imagine a plane. If you imagine a plane passing through this bisecting point, then any point in that bisecting plane, potential will be zero. Okay. So that means that surface becomes equipotential surface. I am repeating. That surface becomes equipotential surface. Okay. Right. Now let us generalize. Let us now generalize because we got on axial line kp by r square on bisecting plane or bisecting line potential is zero. Let us now take at a general point. At a general point, let us take that is now dipole moment vector p bar. Let us say we want to calculate at some distance, and that line makes angle theta with p bar. Okay. Now what I'm doing here, let us take two components for p bar. I'm repeating. Let us take two components for p bar. One is along that line. One is along that line, that is p cos theta. Other one is normal to that line, that is p sin theta. Okay. Now if you observe that point where we want to calculate potential, that is now on axial line for this dipole moment, right? So for this dipole, so p cos theta is acting as one dipole and p sin theta is acting as one more dipole. So this p bar is a combination of two separate dipoles. And for this dipole, this point is on its axial line. On its axial line, potential is V equal to K. I am using now this result, okay? Kp by r square in the place of P, writing P cos theta. So P cos theta by r square using this result, okay? In the place of P, right? P cos theta. Next, coming to P sin theta, for this dipole, that point is on its perpendicular bisector, and on bisecting plane at any point potential is zero. So because of this dipole at that point there is no potential. Therefore, this is now potential due to dipole at a general point. If you take theta 0 in this one, that is axial line. If theta is 90, that is perpendicular bisector. Okay. This is the general one. Kp is cos theta by r square. Okay. Right. Now let us focus on solving problems. See first one. So this is a previous IIT problem basing on calculation of potential. Okay. Right. See once the question given. A non-conducting ring of radius half meter carries a total charge of 1.1 10 power minus 10 coulomb distributed non-uniformly on its circumference, producing an electric field E everywhere in the space. The value of the integral It is integral mi- minus E bar dot dl bar, where L equals 0 being the center of the ring. So we have to calculate now this value in volts, right? Charge given 1.11 10 power minus 10. Our radius is 0.5. And if you observe carefully, this is nothing but potential difference. I am repeating, this is nothing but potential difference. Integration of minus E bar dot dl bar. Limits see carefully from where to where. It is from infinity to 0, right? 0. 0 is now center of the ring. I will repeat right separately here. See once carefully. So what we have to calculate, integral minus E bar dot dl bar. Limits given from infinity to 0. This is nothing but potential difference delta V, or I can say potential at center of the ring minus potential at infinity. Okay, and we are knowing that at center potential is kq by r at center. Infinity potential equal to 0. So this is nothing but potential at center of the ring. Okay, and see that value how much? K value 9 10 power 9, Q given 1.11 10 power minus 10 coulomb, and R value given half meter. Then see how much we get. Half, this is 9, this is 1.1, right? So this is approximately how much? It is plus 2, right? Because 9 into 1.11 means 9.99 into 2, right? Half means into 2. So approximately it is 2 volt. Okay. So it is a very simple question. So answer this now. It is plus 2, right? First option. So this is a question given in 2000, year 2000 for 2 marks, right? Okay. See next problem. Three charges Q, Q and Q are placed at the vertices of a right angle triangle given isosceles as shown. The net electrostatic energy of the configuration is 0 if Q is equal to, condition is given that the net electrostatic energy of the configuration is 0 if Q is equal to, right? Okay, now see carefully how we are going to solve it. Right. So given this is a Q, small q and small q, distance is a, since it is now isosceles, this is also a, right? And this is now root 2a. Condition is now for this system, for this configuration, potential energy is 0. Then see how it is possible. We have taken now here all combinations, right? If you're having n charges, then we have to consider NC2 pairs. That means n into n minus 1 by 2, right? So you're having how many charges? Three charges. So 3 into 2 by 2. It is equal to 3, right? Suppose n value 5, then 5C2. 5 into 5 minus 1, 4. So 5 into 4 by 2, we get 10 pairs. Okay. Okay. Now see here. Now take capital Q and small q. Potential energy will be K into QQ by A plus between these two K into Q square by A plus between these two K into Q by root 2A. Now this must be 0. Condition is that must be 0. Okay. Remind just calculation, right? So K throughout K and throughout A. Remaining is now see what is left here. I can say 1Q, right? Here 1Q and here 1Q. And what else left here? What else left? We want to calculate capital Q, right? I can take capital Q common here. Capital Q or capital Q by A. Remaining is now 1 plus 1 by root 2. That is equal to, I have taken these two, right? Remaining is now minus Q. That implies, sorry, E also cancel, right? Just a minute. E also cancel, right? Remaining is now capital Q equal to minus root 2Q by 1 plus root 2. This is the final answer. Or if you want to rationalize, then multiply up and down with root 2. Then we get minus 2Q upon root 2 plus 2. Either taking like this or you can take like this. Okay. By rationalizing that. Okay. That is the final answer. So this question asked in 2000 year for 2 marks. Right. See next one. The figures below depict two situations in which two infinitely long static line charges of constant positive line charge density lambda are kept parallel to each other. In their electric field, point charges Q and minus Q are kept in equilibrium between them. The point charges are confined to move in the x direction only. If they are given a small displacement about their equilibrium positions, then the correct statements, this is given 2015. Now we can see diagram here. Lambda, lambda plus q. Lambda, lambda minus q. Right. See the first option, both charges execute simple harmonic motion. If you see first one, this is a positive, this also positive. On this one at midpoint, net force equal to 0, right? If you displace this one left side, then repulsion by the left one dominates I am repeating. If we are moving positive charge to left side, repulsion by left one dominates the repulsion due to right one. That means net force will be right side. If you displace this point charge right side, repulsion due to this right one will dominate. That means net force will be left side. That means plus Q executes a simple harmonic motion. Okay. Now see carefully second one minus. This is attracting, this also attracting. If we slightly move minus Q left side, attraction by left one dominates. Then it moves towards left side. Okay. Or if we displace minus Q right side, attraction by right one dominates. That means minus Q will move towards right side. That means here oscillations are not possible. Okay. That means answer will be charge plus Q executes simple harmonic motion while charge minus Q continues moving in the direction of its displacement. So option C is the correct one. Okay. Okay. See next one. Consider a system of three charges q by 3, q by 3 minus 2 q by 3 placed at points A, B and C respectively as shown in the figure. So take O to be the center of the circle of radius R, angle CAB equal to 60. Okay. So in this what we have to calculate C once. Electric field at point 2, potential energy of the system, magnitude of the force between charges at C and B, potential at point O is. I think among these we can verify easily option D. Check once. Charges q by 3 minus 2q by 3, right? You can see A, B, C all are at the same distance from center. Okay. Now here, sum of the charges becomes 0, right? Minus 2q by 3. This is now becoming 2q by 3. Since distances are same, just focus now what is the total charge. Now total charge is 0. That means at center potential will be 0. So option D, it is not correct. Okay. Next. Next we can verify option B. The potential energy of the system is 0. Check it once. Potential energy means what we have to focus. We have to focus all three combinations AB, BC and CA. Okay. Now see carefully. Here angle 60 means between A and C separation equal to R. Right. I will make a diagram separately to make it clear what we have to calculate at a point O, at a point O direction of the field. I think this point we can directly verify. See once. At A, q by 3. At B, q by 3. So this q by 3 and this q by 3. You just imagine at a point O, there is a unit positive charge. So we have discussed that whenever to calculate electric field at a point, at that point imagine unit positive charge, right? So at center O, imagine a unit positive charge. Then force by Q by 3 at A, force by Q by 3 at B, both will balance each other because A repels towards B, B repels towards A. Both will get cancelled. Remaining is now only because of C, right? And C is now negative charge. Negative is attracting this positive charge. Therefore, net will be towards C. Okay. Now coming to option. It is given value, right? Direction wise, it is correct along the negative x-axis. But coming to value wise, value. See how much we get? KQ by R square. Q value 2 by 3. I'll make calculation here. So field because of C. K means 1 by 4 pi epsilon naught KQ. Q value, I am taking only modulus here, 2Q by 3 by R square. See value how much? 2 here 2 times. Remaining is now, it is a Q by 2 times. Remaining means it is how much? 6 pi epsilon naught R square. Okay. That is now field because of only point C. Right. Okay. Next they're asking what value given is, we got here 6 but it is given value is 8. So first option is not correct. Okay. Next we have to focus force between B and C. I'll make diagram once again here. Okay. Approximately circle. This is now center. And where is C? This is now C. And this is B. And this is given as A. This is now 60. Right. Now in this we can say this is 60. Now this angle becomes how much it is? It is 90, right? Okay, this is 90 and this is 30. Now BC value, BC value how much means? It is a 2R sine 60. Okay, so BC value how much? It is a 2R sine 60. So once we get BC value, we can find force between those two, right? See how much we get? Force between B and C. Force between B, C. 1 by 4 pi epsilon naught. Q1, Q2. That means Q by 3. 2Q by 3. I am focusing only here. Modulus of the force. Okay, that's why not taking minus here. Q1, Q2 by R square. R square. Distance how much? Root 3 by 2. This is R root 3. So this is R root 3 whole square. Right. Then see how much we get. 1, 2 here. Here 2 times. Next Q square. This is a 9. 9 and here it is 9. 27. 27 to 254. So it is now Q square by 54 pi epsilon naught r square. That means option C is matching, right? Q square by 54 pi epsilon naught r square, right? Option C is matching. See, right. Okay. So among this, only correct one is option C. Okay. No? Okay. Now see next problem. A positively charged thin metal ring of radius r is fixed in the xy plane with its center at the origin O, and negatively charged particle P is released from rest at the point 0, 0, z naught, where z naught greater than 0. Then the motion of P is, this is a question asked in 1998 for 2 marks. See options. Periodic for all values of z naught. Simple harmonic greater than 0, less than or equal to r. Here r stands for radius, right? Approximately simple harmonic provided z naught very small compared to r. So this point we can select directly here. Just matter of single step. Just recollect once. Recollect once. Expression for electric field on the axis of a circular wire. On the axis of a circular wire. If you remember distance x, if you have taken, field is kqx by r square plus x square whole power 3 by 2, right? Suppose you're placing a charge here, it is a q naught, then force becomes into charge. This is now force. Now in this, if you consider, means one is now positive, one is negative. If you consider x is very small compared to r, then that can be taken as f equal to minus k into q naught into x by it is r cube. Why minus means because one is a positive charge, other one is negative charge. So it is negative. When x is very small compared to r, x square also very small compared to r square. Therefore, this becomes now simply r cube. So here, force is of the form minus something into x, right? And that something is nothing but force constant. Okay. Then if they ask like what is the time period, we can calculate time period equal to 2 pi root m by k. In the place of k, what we have, right? K into q naught by r cube. Means if they ask, okay. Right. Now in this, only option C is the right one. Right? Reason is that when z naught is very small compared to r, it is simple harmonic. So A and B are not correct. Okay. Wait, actually here option A. Option A also possible because they're asking periodic for all values of z naught satisfying greater than 0 and less than infinity. Because this is what we can say by using energy conservation. It will be periodic. Okay. But not simple harmonic. Coming to here, P crosses O and continues to move along the negative z axis towards z equal to minus infinity. See, this is again not possible because according to energy conservation, it should come to rest momentarily and again moves back. Okay. So option D is not correct, right? So option A, periodic, that is possible, right? Next, option C. So these two are now correct options. Okay. That is the last one. Right.